Thank you for joining us today. I'm your host, Nando Mogollon, and today we will be looking at part 3 of the coordination stage. We will be focusing today on the collision detection using Archicad. We'll keep using our dedicated coordination file, as you have been following in the previous webinars, which is a PLN file with a lot of the other files, Ifc files linked in. But the difference is that in this coordination file that we keep as an Archicad file, we will have the architectural file as an Ifc. So, assuming that we have performed some level of visual coordination as we did in our previous webinar, now we would like to take a look at the collision detection feature in Archicad and some of the tasks that can be done with it. So today we will be specifically looking at the collision detection for services coordination. We're going to take a quick look at that. I'm going to take a look at the stairs clearance using the headroom option for the stairs. And we will take a look at finding elements in specific areas of the project that may be problematic, which can be done using the same tool. So before we start, let's remind you a little bit of the context. Beam authoring tools like Archicad are not quite designed to perform specialized coordination tasks, but some basic tools are available, and we want to make sure that you can use them and they can take advantage of them within the projects you're working. Some of those tools, as you know, trace and reference for visual coordination, as we did in part 2 of the webinars. Graphic overrides, same thing, which we also demonstrated in our previous webinars. And of course, this one here, which is collision detection, a embedded feature of Archicad, which is based on solid geometry. So Archicad is no different from any other beam authoring tools. You'll perform certain things, but it's never going to be as specialized as a coordination tool as there are out there. Let's take a quick look on how these can be used to perform some of the coordination tasks. So let's jump right ahead. So let's start by taking a look at the project we've been working on. This is the file, the coordination file, where I have essentially just 2 Ifc files linked in, the structural file and the architectural file that was produced by myself with my working file. The first thing we want to do is to do a typical finding clashes with the collision detection, right? So to do so, we'll play a particular role where we'll imagine we're going to coordinate the mechanical or plumbing file with the structural file of this building. Now, we don't have a full model for that, but you can do quite a few things mimicking some of the model elements that may come from a project like that. So let's start by going to the basement, where I have made a little mock-up of what we will find typically in a situation like that. And we will be looking at something that, can be representative of a typical project. You will receive a model for plumbing and hydraulics, and that might be represented here. Let's say that those yellow pipes might be drainage. So let's assume that's an incoming Ifc file. And the rest of it are the Ifc files coming from the structural engineer and our own very architectural file. So the first thing you want to do in order to get into the collision detection is to go to the design menu. And right about there, sort of close to the end, you'll find the collision detection option. That will trigger a pop-up window like so, which you can use. Let me clear up this a little bit, which you can use to set how the collision detection will be performed. So let me take a quick look at this so you can see what it's all about. It's based on 2 groups. So essentially you will define based on search or finding criteria 2 different groups, and what Archicad will do is simply to collide those 2 groups looking for clashes of the geometry. So you'll define one group right there, another group right here, and then lastly, a few of the conditions. The conditions are based on tolerances, so you can actually set some level of tolerances, which might be useful, particularly for the case of, say, piping, where sometimes some of the minor or smaller diameter pipes might be not considered since they may be just simply okay. Same thing for surfaces. So things that are just touching each other might not be considered a collision if the value for the surface tolerance is it's set fairly low. I'm not going to play with that right now since we just have a few examples in there, but that's basically what these values will do for you. Now, the rest of this will be for you simply to define. Now, in here, that's where you find the criteria for group 1 and group 2. You'll find these to be very familiar to some other interfaces in Archicad, mainly the find and select criteria. So you can build your own criteria here simply by saying, all right, I want you to go and find me anything that might be on a particular layer or similar. But what we will recommend to you is that rather than start building those things from here from scratch, you can actually predefine those based on search, find and select tools inside Archicad. So let me close this for a bit. And if I just hit Command F or Control F, depending on whether you're on a Mac or Windows, find and select will allow you to set certain criteria and then to save that criteria. So you can, at any point in time, jump back to any of those selections. So we recommend you to do that in here so you don't have to build that all the time when you're doing the collision detection, right? So build the criteria up, save it just by clicking in here and store as, and then give it a name. And by doing so, the whole collision detection will be far quicker. So let's start by doing the typical detection between pipes and structural elements. So the way we're going to do that is simply by taking this group, clicking this option here, and then I'm going to load one of the criteria that I have already set for this particular exercise. So I'm going to use the hydraulic model, which is essentially a criteria that looks for anything that is on this particular layer, assuming that's an incoming IFC. And then group 2, I will define it as any, let's say we're going to clash these against walls, right? So let's use the architectural walls initially, right? So that's going to bring any 3-dimensional types as long as they are load bearing, as you can see there, and classified as walls. So that's all you need to do. And then the next step will be simply to click on check. When you do that, what you're going to get is a list of issues that, because I'm using Archicad 23, are still called markups, but in Archicad 24 and forward will be called issues, but they're all basically and essentially the same. Now let's go and click check. I get a tiny little report basically saying, look, I've found so many items as I've defined the group 1, and I've found so many items on group 2. And based on that, I've created so many collisions and so many markup entries. If you click on continue, now we get the markup tool, or what in Archicad 24 will be your issue management list. And you get a list down here that is based on those clashes. So since we just found one, you just have to switch that on. That's going to get highlighted. As you can see, there are 2 elements in here, and I can see them there. You can select them if you like. That will be selecting the wall and the pipe. And therefore, you can add, if you like, to this particular issue, which is found by the collision detection. You can actually add a screenshot like so, populating this view down here, and you can add more information about it. Now, we're not going to get into that right away since we will focus on managing issues on a future webinar. So keep an eye on that because that's going to be on one of our future webinars fairly soon. So that's how you find the issues. They're going to create a list down here. Even if you are looking somewhere else in the file later on, say pointing that way, if you want to go and take a look at that, all you need to do is go back to this attached view and click on apply view. By doing so, Archicad will set you back to the position where you were initially looking at that particular issue right there. All right, so that's what we have there. Let's take a look at a couple of additional things in here that may call your attention. One of the things you'll find is that, sure, you found an issue there, but if I go back a little bit here, you'll find that I also have another wall right here, and that wall is also penetrated by the same pipe. But Archicad didn't find a collision for those, right? And the reason why, it's something that is quite not evident following just the process that you just follow. But if you know the nature of the building materials in Archicad, you will realize that this is an exception to the rule because the collision detection may or may not be detected or available for all materials. So if you go and check your building materials, you'll find that things like insulations will have an option almost all the time down here that says participates in collision detection, and the checkbox is not ticked, meaning that this material itself will be ignored when you run collision detection tasks. So that is why you don't get that. And the reason why you don't want to get that is because, as you can imagine, insulation may be running in between two solid or two load-bearing or core elements, and piping may be running through that without having to be necessarily a collision, since, you know, the insulation will be flexible enough to let the pipes run through. So that's the reason why that's not being set as to be participating in collision detection. And therefore, the reason why this particular wall didn't cause a clash with that particular pipe. Now, in this particular exercise that we're doing here, I have a coordination file where most of the elements in this particular file are not embedded in the file. But if you were doing this with some of the elements in your working file, then you could edit your walls and other elements. So the most common workflow for that exercise when you're coordinating, particularly against mechanical and hydraulics, will be to solve that problem right away if it is up to you to sort out the problem. The way you'll do that is by providing an opening around that pipe, therefore not causing a collision anymore. Now, you could do that simply by using your opening tool and then, you know, locate an opening close to the pipe, but that will be a manual process. And as you can imagine, probably don't want to do that since it will take quite a lot of time given the typical mechanical or hydraulics file. So you actually want to automate that. The way you do that, let me step back. The way you do that will be simply by taking this pipe, now that it's been found as a clash with that particular wall. You can do a right click to it, use the connect option, create openings from selection. That option will ask you what's going to be the shape of the opening that you want to create. Let's say we still want to have a rectangular one with just, say, 10 millimeters around it as an offset or tolerance. And then you just click create opening. You don't need to select which wall, since it will find that this is the wall that is actually creating the clash, to the point that this one here doesn't create an opening since it is not needed for the insulation. So if the pipe was, you know, going through several walls, then several openings will be created. So that will be a way to automate the process of coordinating with some things like pipes. Now, there are a few other exceptions, just like the insulation in this particular case with this wall. There is also the fact that clash or collision detection will be sensible to all the layers that are on, not necessarily just visible on your 3D view, but the fact that the layer is on in your list. So make sure that layers are active and visible according to the list, so that they will be included in that particular collision detection. There is another case for finding elements, and as you can see, when I did the exercise of finding the clashes with the collision detection, I did have, since we're dealing with IFC files and we're heavily focusing on IFC, I had the load bearing set to be true. So I only wanted to find clashes against load bearing elements, which is, as you know, an incoming property of the IFC files. Now, if you try, you'll see that any IFC property is not quite visible here. So even if I click here, you'll find that IFC properties are not available from this list, right? And even if I save it, as I did right here, if I saved the IFC properties in my find and select criteria, they won't be available through here. So that's one of the limitations and one that you need to keep an eye on. Nevertheless, you can still have access to that, which is what I did here, by mapping, by using your dedicated translators, mapping those IFC sets back to your Archicad properties. So let's take a quick look at that so you can see where this is coming in. So the translators I've used, as you know from previous webinars, I've used dedicated translators for both the architectural and the structural model. And what they do is effectively mapping load bearing for any elements, and specifically columns, slabs, and walls back to an Archicad property. So you can type that in, or you can merge from the individual files. So the only thing you need to do is to make sure you have a dedicated preset for the property mapping, where you're not just simply going to dump in the IFC properties. You actually want to transfer the ones you want to use from IFC back to Archicad properties. So those properties must exist before, and then you just link one to the other, and then you can use the Archicad properties in your collision detection. That will be a case where you want to use something like load bearing or fire resistance back in the collision detection feature. Now that we've taken a look at that, a typical look at those bits and pieces, another one that might be related to ventilation, for instance, services, but let's say ventilation in this particular case, will be, terminals and things that will be visible. Things like pipes tend to be, hidden in the ceiling voids, but the case of terminals or, something like a ventilation diffuser might be visible and relevant to the architectural design and interior design. So you may have this piece, the diffuser, coming from the IFC mechanical file while your ceiling is sitting in your architectural file. So you can actually follow the same process with a bunch of them, and you don't have to do the cuts manually. The way you do that is simply, following a similar process. You will select the diffuser, do right click, connect, create openings, give it an offset or not, depending on what is needed. And now the diffuser will create an opening for itself in the ceiling. So similar to that, you will be able to create, host those diffusers or lights or, sprinkler and similar into your architectural file. So easy to coordinate simply by doing that. Let's close this markup tool. And now let's move to the second example we wanted to check, which is the headroom clearance for stairs. So I've got a mock-up of a stair down here, as you can see there. So it's a little mock-up with a stair, and I just have a typical situation there where we have a ceiling bulkhead just running there. It doesn't seem to be too problematic, and it seems pretty normal to have in a situation like that. So we have the stairs there, and with your model view options, you can actually display the headroom clearance of the stairs, which is a property of the stairs inside Archicad. Now, the case is you can actually use that with the collision detection. It's just not available elsewhere, simply only when you're running it through collision detection. Let me show you that. So the first thing that you will need to do, and it is a condition in order to make sure that the collision detection for clearance on the stairs will work, is to make sure that the headroom must be visible. And the way you do that is by using your model view options right here. And the stair options must have this checkbox activated so that the headroom will be displayed. The height of the headroom and the offsets, the lateral offsets, will be set on stair by stair basis. So that's driven by the settings of the individual stair. But once they're set up, they will be visible. From here, you simply will run the same collision detection. It's just that this time, rather than using these criteria, I'm going to use another preset criteria that I've created already, architectural stairs, one side, and I'll use, let's say I've got ceilings down here. Any ceilings. Now, these won't be enough, actually. The fact that you're adding stairs and the layer being on the right layer, you actually need to tell the selection criteria to focus specifically on the headroom. So the way you do that is simply by adding a criteria. You type stair model. This is what will do it. And then you choose to check for just the headroom, right? So now what you have in here is two different groups, the headroom of the stairs and then some ceilings with whatever tolerance you decided to be. Go click on check, finds the two groups. And now what you get is, just like with the other one, you'll get a highlight of the elements that are involved in this particular process, where we can see that it is actually there, the bulkhead, which is giving us a problem there. So that might be difficult to catch if you're just looking at drawings, but by using the feature, you can find that and then do the necessary adjustments. And then to wrap up, let's go and take a look at a different way of doing a detection, which is a way in which you can actually try to find problematic elements simply by defining an area. So the way you'll do that is you will define an area by using the zone tool. For instance, I'm going to do this exercise by defining a fire zone. So I'm saying, look, this particular area, this facade here, since we've got certain conditions on the site, that requires to be on a particular fire rating level. Or let's say all the elements that are involved in this piece of the facade, let's say down there and up to level 5 or 6, they need to have a specific fire rating. And I want to check if the elements have the necessary IFC value in the fire rating property. So the way you do that, once you have mapped the IFC property, as I showed you a couple of minutes ago, the way you'll do that will be by performing the same collision detection. Let's go back here. There you go, collision detection. And now the two groups that I will define will be setting the elements on the facade that might not be fire rated. And let's build up the zones actually. So I may go and say, look, just find me zones that don't need to be on that classification. I can use a name, although in this particular case, these are the only zones. If I wanted to be very specific, I'll probably define it by the name, but I'm just going to avoid doing that since I'm going against the time right now. So what these will do is to find any walls or curtain wall panels or ceilings that may not have a fire rating defined. So this is a typical convention for fire rating. So if it's not defined, it's typically set to this value. So I want to go and check a look if there are any of those within that area that I have defined in there. So simply go click on check. Group 1, there are about 3,000 elements, all of those wall plates and ceilings. In group 2, we have those 2 zones because I have one on top of each other, but only 176 will be found to be critical. So 176 of the elements in that area do not have a fire rating. So you want to check which ones are those. You will follow the same process. Right now, but of course, we do have far more elements, as you can tell. But at least now I can just simply go and select, say, all of them. Switch on the visualization for that. They will be selected right there by default. Switch them off. You can actually, if you want to find them visually and separate them or isolate them in your 3D view, what I'll do is simply click on the selection, unselect the zone, and then you hit F5. So now I have much better visibility over which elements do not have a fire rating. So that will be the ones. If I want to report on that, same thing. I can simply take a look on any of these bits and pieces. Let's say we select just the first one and capture the view, and we can report on that based on this selection by the zone. All right, so there are many other ways to use the collision detection, structural versus architectural, which can be done, although we show you some of that with the visual coordination. Only architectural elements, like the one we just did with the define zone, and a few others that will relate it to, doors of, size of doors, size of or height of ceilings, or heights of parapets, and so on. So as you can see, beam authoring tools like Archicad can do quite a few things, but it won't be a match for specialized beam coordination tools, which we encourage you to take a look at. Specifically, probably Solibri, which is by far one of the most powerful tools for the purpose out there. Archicad is not a replace for those, but we want to make sure that you can use these features, specifically when it comes to coordinate against your architectural file and being able to modify your file accordingly. I hope you enjoyed the last few minutes of the webinar. Please subscribe to any future webinars by following that link, or if you have a cell phone, just point at this QR code. That's going to take you to the calendar where we have all the future webinars that are coming. We're also announcing with a few days in advance these webinars on LinkedIn, so you can also keep an eye on that. Getting help in Australia, you can call the support line on that number there on the screen, or log in tickets via my CI. Our emails for support both in Australia and New Zealand are as on the screen. So don't forget to register and check all the material that we have at myci at centralelevation.com. Stay tuned for the next week's webinar of the series, where we're going to start taking a look at reporting those issues and communicating with other stakeholders. Till then, have a good time.